document camera. All right, and so we are working on problem number 1. All right, so let's read problem 1. All right, so problem 1 gives you this graph. It says this is a graph of g, and it says the function g is defined on the closed interval -4 to 8. The graph consists of 2 linear pieces and a semicircle as shown in the figure above. Let f be the function defined by 3x plus the integral from 0 to x of g of t dt, right? All right, so part A says find f of 7 and f prime of 7. All right, so first of all, f of 7 is just a function notation thing. So f of x is this, so we're just gonna take f of 7 and replace x with 7. So 3 times 7 plus the integral from 0 to 7 of g of t dt. All right, and so that's all we have to do. All right, so 3 times 7, of course, is 21, but you could just leave it, right? If you left it as 3 times 7, that would be fine, all right? But then plus the integral from 0 to 7. All right, so we have from 0 to 7, all right? All right, so integral from 0 to 7. Now, remember, this is a semicircle, right? But that goes from 0 to 6. So we need to find the area here, right? And remember, it's below the x-axis. All right, and then we need to find the integral, remember, all the way to 7, and 7 is here, so we have to use this. Now, some people forgot about that little section, or some people went all the way to the other endpoint to 8, all right, and so that was a couple common mistakes. All right, so what is this? This is half of an area, half of a circle, right, with a radius of 3. And so you take pi times 3 squared, right? But remember, it is below the x-axis, so it's negative, right? So we have 21 plus negative 9/2 pi. And then we've got this section here. It's a rectangle. It's 1 wide and 3 tall. And so we have a rectangle of this, right? So of area 3. So 21 minus 9/2 pi plus 3. Once again, I've said this so many times on these live meetings here. Do not simplify. You don't have to simplify. Amazingly enough, one of you had this, and then the line below it, you wrote this. And guess what? You now don't get the point for this question. If you would not write this, then you get the point. So 21 minus 9/2 pi plus 3, obviously 24 minus 9/2 pi is the correct answer. All right, so that is just worth 1 point. It's if you have this answer, you get 1 point, and if you don't have this answer, you don't. All right, but then f prime of 7. All right, so if I want to find f prime of 7, I first of all have to find f prime of x. All right, so first part, we have the derivative of 3x, which is just 3, plus the derivative of the integral from 0 to x of g of t dt. So remember, second fundamental theorem of calculus, we use from section 7.4. So we're going to put x in for t and multiply by the derivative of x. So f prime is 3 plus g of x. Okay, so that is f prime of x. So then f prime of 7 is going to be 3 plus g of 7. So g of 7, what does that mean? Remember, this is the graph of g. And so we just go to this graph at x equals 7, and the y value there is 3. So 3 plus 3 is, of course, 6. And so f prime of 7 is 6. So this is worth 2 points, 1 point for f prime of 7 and 1 point for f of 7. Any questions on part A?
Right. Somehow I got both those answers right.
Okay. Any questions?
I somehow managed to get those answers right. It's the rest of the problem one that just kind of threw me off.
Okay.
That 3x.
All right. Any other questions?
For some reason, whenever I do these questions, I'm always kind of confused on when you're supposed to find the area and when you're not supposed to. So what's a good way to understand?
Remember that f is defined by this integral, right? And so when I say f of 7, remember, it's just function notation. You're just plugging 7 in for x. And so if I want the integral from 0 to 7, then that's an area question. But when I say f prime, now I'm taking the derivative and I'm using the second fundamental theorem of calculus, so it's no longer defined by the integral. And so then I'm actually using the y value. And then if I were to say like f double prime, which is also a common question, like what would be the case if I said, what is f double prime of 7? What would that be asking for? L.
Well, that would be the slope of g of x at 7.
Right, and so in this case, it would just be 0, right? Because it's just a horizontal line. Okay, so, you know, it's most of these problems are structured in this way. So if I had to guess, you're going to have a problem that's going to have a graph, and it's going to say like a graph of g, you know, but then g is probably going to be somehow related to the derivative of f, right? You know, something like this, okay? This is a really common question, and I think that this is very likely to show up on one of the problems, okay? And so then you're going to be asked to find like f of 7, f prime of 7, and then it's very likely that you're going to be asked to find the second derivative, which is just the derivative of this graph. Okay, and we've done a number of these. You can always go back and look, you know, and there's some additional practice. So if you see a problem like this, then this is one certainly to practice. Okay, anybody else? All right, then let's go on to part B. All right, so part B says find the value of x on the closed interval -4 to 3 at which f attains its maximum. All right, so if I want to know when a maximum occurs, I want to examine like a sign analysis of the derivative, right? And so if I want to know where the maximum of f is, I want to know what f prime is, right? I want to know what the sign of f prime is, right? So f prime, what we already did is we figured out that f prime of x is 3 plus g of x, right? Now this is unique. Think about this, 3 plus g of x. So this is a graph of g. What would a graph of 3 plus g of x be? It would just be this graph shifted up 3 units, right? And so if I shifted that graph up 3 units, right, then that means that the semicircle would come down as low as there, right, as low as 0, and then we would have this line segment over here, and then this line segment over here, right? And so if this is a graph of f prime, what do you notice about f prime? It's positive everywhere except at x equals 3, where it's equal to 0, right? But everywhere else it's positive. So if f prime is always positive, what does that mean? F is increasing everywhere, right? F is increasing on the domain -4 to 3, right? Because that's the domain for this question. So if f is always increasing, then what does that mean about its maximum? F attains its maximum at x equals 3. Why? Because f prime is greater than or equal to 0 on the entire domain, so f is increasing on that entire domain. So relatively simple question. Very common mistake was that people said that because this graph crosses the x-axis at 0, right, it changes from positive to negative, which would be a local max. Well, that's not true because of this 3x added on the outside of that integral. Okay, you didn't actually need to find the value at x equals 3 because it just says find the x value at which f attains its maximum, and it doesn't say find the maximum value. Now, if you did find it, that's just fine, all right, but you didn't need to do that.
X equals, so it's f attains its maximum value at x equals 3 because that's where f is 0 on the graph?
No, it's not because it's where f is 0. It's because from -4 to 3, there would only be 2 critical numbers, the endpoints, -4 and 3. Right now, yes, 3 happens to be a 0, but even if it wasn't, like let's say it was like, you know, x equals 4 or x equals 2 or x equals, you know, 8 or whatever, any other value, because this f is positive everywhere, right? That means f is increasing, then it would attain its maximum at the right-hand endpoint.
So because so it attains its maximum value because it's always increasing?
Correct. Okay, now the thing that a lot of people did was, like I said, you forgot that it was like the 3 plus g of x, So if f prime was just g of x, then the maximum would have occurred at 0 because the derivative changes from positive to negative. And that's what a lot of people considered, but that is not the case for this problem.
As long as I thought this was, I just looked at the graph and found where's the highest point on the graph instead of just realizing that this whole entire graph was shifted up 3 units.
Yeah. All right. Any other follow-up questions on part B?
Just a quick follow-up thing to point out. Bono, can you flip back to part B?
Sure.
And I don't know, Bono, if you had any of the people who answered like this, but keep in mind that the problem is asking at what x value. So I had a few students whose answer was like f of x equals and whatever that y value was. So you actually answered with like what the maximum is, not where did the maximum actually occur. And for a lot of you, you were correct in what the maximum is, but you never actually stated that you were even evaluating like x equals 3. So just, be careful to answer, especially with those maximums, if it's asking the x value or the y value.
If it just says find the maximum, does that mean the x value?
That's the y value.
Yeah.
Okay.
So this question said, find the x value at which the maximum occurs. So you don't have to find the y value, but it's possible in a different scenario that you're doing the critical number test and then you would be finding the y values to compare them. But usually, if they say find the x value at which the maximum occurs, the problem can be done in such a way that you don't actually have to know those y values. It's more than likely based upon the sign analysis of the first derivative. Okay. All right, can we move on to part C then? All right, part C. All right, part C says, for each limit as x approaches 0 from the left of g prime of x, and the limit as x approaches 0 from the right of g prime of x, find the value or state that it does not exist. All right, so the limit as x approaches 0 from the left of g prime. So what are we asking? Now remember, this is a graph of g, right? So if we're looking at a graph of g, what does the limit as x approaches 0 from the left of g prime mean? Well, if I'm approaching 0 on the left, right? I'm moving this way. It's saying, what is the slope of the tangent approaching as we get to 0? Well, this is a line. So the slope of the tangent is the same at every point along this line approaching 0. And so what's the slope of this line? So the slope of that line is -1/2. And so that's it for the limit as x approaches 0 from the left of g prime, -1/2. No work to show, and it is just 1 point if you have that, and no points if you don't. All right. Now, on the right side, the limit as x approaches 0 from the right of g prime. So now we're just moving along this semicircle. Now, you see this slope is some negative slope, right? And as you approach, it gets closer and closer and closer. But remember, as soon as you get to 0, right, this slope is going to be vertical. And so you would state that the limit does not exist. Okay, now it doesn't say give any justification or anything like that, but what would your justification for this limit being does not exist? It would be that it's a vertical, right? Now, a lot of people wrote infinity. Now, infinity is actually not correct. Why is infinity not correct? Because notice how these slopes are negative, right? So it's actually approaching negative infinity. And so if you wrote positive infinity here, by my estimation, that would be incorrect because it's not approaching positive infinity, it's actually approaching negative infinity. But it does say, just state that it does not exist. And remember, infinity is not a number, so you would want to state that it does not exist.
So what exactly is the limit as x approaches 0 from the right? Because it's approaching, because it's a curve approaching 0, like.
Well, remember, we're asking what are the slopes of the tangents approaching, right? Because we're asking for the limit of g prime, right? And so these slopes are negative, and then they get steeper and steeper and steeper until right at that point, it would be a vertical tangent line. And so that would be approaching negative infinity, and negative infinity does not exist in a limit question.
So that makes sense.
Okay. All right. Any other
Staying-
follow-up questions on part D?
So we're just taking the slopes for these.
Yeah. I mean, it's just saying the limit of the G prime. And remember, that graph is just G, right? So we're just looking at the slopes on the left side and the right side. All right. So that's C. All right. What about D? All right. So let's move on to part D. All right. So D says find the limit as x approaches -2 of f of x plus 7 divided by, what is that? I got to zoom in. It's so small. E to the 3x plus 6. Is that right?
Mm-hmm.
Minus 1. All right. So what is the first step in a limit problem? Okay. First step is to evaluate, right? And so we're going to evaluate, and we get what? F of -2 plus 7 divided by e to the 3 times -2 plus 6 minus 1. Okay, now, I did have somebody who, sorry, I forgot about the plus 6. I did have somebody who wrote this and just like stopped doing the problem because they're like, oh, I don't have to simplify numeric. It's like, well, you got to do a little bit more because you totally missed the whole point of the problem. So there are some points at which you probably should, do some simplification because you really haven't touched on the problem. All right, so what is f of -2? So you have to remember that f was defined how? Remember that f of x was 3x plus the integral from 0 to x of f of t dt, sorry, g of t dt, right? And so f of -2 is going to be what? Well, it's going to be 3 times -2, all right, and then plus the integral from 0 to -2 of g of t dt, and then you've got the plus 7, right? Okay, and then in the denominator, obviously, we could simplify a little bit. 3 times -2 is -6, plus 6, of course, is 0. E to the 0 is 1 minus 1. So the denominator is going to approach 0, right? And if you had to guess, what would you think the numerator would be approaching?
0.
Right? Remember, it's really not that interesting to give you a limit question that doesn't approach 0 over 0. It's possible, but you really want to make sure that if you're not getting a 0 over 0, you may want to kind of re-examine what you've done there. All right. So obviously, 3 times -2, of course, gives us -6. All right. But now, what about the integral from 0 to -2? All right. So what is that? Well, if we go back to the picture, right, we're looking for this section here, right? But remember, we're going backwards, right? So if I had the integral from 0 to -2, what would we normally do, right? We would normally say, okay, well, I'm going to put a negative out front, and I'm going to write from -2 to 0 of g of t dt, right? And then I've got the plus 7, right? All right, so now, what is the integral from -2 to 0? So now let's examine that triangle, right? So this has a slope of -1/2, so it has a height of 1 and a width of 2. So half of height of 1 times a width of 2. So half of 1 times 2 is, of course, 1, right? And so we would be subtracting 1. So we have -6 minus 1 plus 7 over 0, which, of course, is 0 over 0, right? All right, so now 0 over 0 means we can use L'Hopital's rule, right? So what do you want to do to make sure that you can use L'Hopital's rule? Well, you want to state that the limit as x approaches -2 of f of x plus 7 is 0, and the limit as x approaches -2 of e to the 3x plus 6 minus 1 is 0, right? And what else are we supposed to state? That f of x plus 7 and e to the 3x plus 6 minus 1 are continuous and differentiable at x equals -2, right? And so if that is true, then we can use L'Hopital's rule. So L'Hopital's rule says that the limit as x approaches -2 of f of x plus 7 over e to the 3x plus 6 minus 1 would then equal the limit as x approaches -2 of f prime of x, right, plus 0 divided by the derivative of e to the 3x plus 6 minus 1, which would be 3e to the 3x plus 6 minus 0, right? And so then we would reevaluate, and we get f prime of negative 2 divided by 3 times e to the 3 times negative 2 plus 6. All right, and so then f prime of negative 2. All right, so if we go back here, all right, f prime of negative 2, so that's right here, so that's just this slope, right? Oh, I made a mistake.
Oh, yeah.
Do you recognize the mistake?
Yeah.
The derivative of f of x is f prime of negative 2, but what is f prime of negative 2? It's 3 plus g of x, right? Everyone agree with that? F prime was 3 plus g of x, so we're looking for 3 plus g of negative 2. I apologize for that. All right, and then divided by 3 times e to the 0, so that would be 3. All right, so then what is g of negative 2? All right, so g of negative 2, we go here. G of negative 2 is 1. And so we have 3 plus 1 over 3, or 4/3.
There we go.
All right, so there's kind of a lot of work that I did there, but really most of that work was just showing that this was 0 over 0, and then making sure I make these statements so that I justify the use of L'Hopital's rule, and then using L'Hopital's rule and then simplifying, right? And so we get 4/3 as the answer, and that is worth, what is it worth, 3 points? This is part D, worth 3 points. All right, so 1 point for getting that the limits of the top and bottom equal 0, 1 point for applying L'Hopital's rule, and then 1 point for the answer of 4/3. Now, there is a note that says there is a max of 1 out of 3 if no limit notation attached to the ratio of derivatives. So this is where Alina is going to get mad. She had something like this, where she did not have a ratio of the derivatives in a limit notation, and so the best you can get is 1 out of 3 there.
I completely made a mistake in this problem that I did not realize, because I accidentally put in -2 as 2, and I didn't realize I could have just swapped the numbers around and got an easier area, and I accidentally looked at x equals 2 and calculated the wrong area.
Okay.
And I just got upset.
Any other follow-ups?
Yeah,
Alina, rebuttal?
Bono. So
Yeah.
you have to specifically state that it's continuous and differentiable. You can't just write L'Hopital's rule.
Yeah, was that like one of the points? Like you have to write because I solved it for 0 over 0, but I didn't write that each one was equal to 0.
So what we have said, what has been the case recently in terms of the past couple years is that they have said that if you do not separately state that the limit of the numerator is 0 and the limit of the denominator is 0, and also state that both the numerator and denominator are continuous and differentiable at that point, then you're not going to get that point for, justifying L'Hopital's rule. So I know it seems annoying and it seems tedious, but if you know how to do it, make those statements and move on and get the point.
No, I have a question.
Yes.
So if you have that, the limits are both equal to 0 and that it's continuous and differentiable, do you have to have the little L indicating that it's?
Well, so if I don't have that, I've never really said anything about L'Hopital's rule, so I should say L'Hopital's rule, but they do accept the L with the circle to indicate using L'Hopital's rule.
All right.
Okay. All right, any other follow-ups on part D?
Yeah, I don't know if I'm going to get at least 1 point from this problem, because even if I made many miscalculations of this problem, I recognize that this was a problem that I could have used L'Hopital's rule with, and I did state that things you need to state if you're using L'Hopital's rule, so that should hopefully be enough to get me at least 1 point for
Yeah.
this problem.
Yep. All right, let's move on to question number 2. And if there's more questions on 1, we can always go back if we need to. All right, so question number 2. All right, I think the results on question 2 were a little better based upon the fact that we did implicit differentiation just the other day. But all right, so for 2 says, consider the curve defined by 2x squared plus 3y squared minus 4xy equals 36. All right, and A says, show that dy dx is 2y minus 2x over 3y minus 2x. All right, and so the way to approach this is to take the original equation. All right, this is a section 3.5 question, and we're going to take the derivative with respect to x of both sides. So d dx of 2x squared plus 3y squared, and then minus 4xy, all right, and then equals d dx of 36. All right, so on the left side, we're taking the derivative with respect to x. So the derivative with respect to x of 2x squared would be 4x, and then like we talked about the other day, you might write like dx dx, but that's just 1, plus the derivative of 3y squared, which would be 6y dy dx, don't forget about the chain rule, and then minus, now we've got 4xy. So I have 4x times the derivative of y, which would be dy dx, and then plus y times the derivative of 4x, which would be 4, right? And then equals the derivative of 36, which is, of course, 0. Now, I had a bunch of people who took the derivative of the left side and seemingly knew that the derivative of 36 was 0, but then they didn't even write like equals 0. They just kind of like stopped writing, and then it was no longer an equation. You want to make sure that you maintain the integrity of the equation. All right, and so now I would just distribute the minus sign. So I've got 4x plus 6y dy dx minus 4x dy dx, and then minus 4y equals 0. And so now my goal is to solve for dy dx. So I'm going to group together the dy dx on the left side and factor it out. So then I have 6y minus 4x equals, and then I'm going to bring these others over. So I have 4y minus 4x. And then I'm going to divide. So dy dx is equal to 4y minus 4x divided by 6y minus 4x. And then you can factor out a 2 in the numerator and denominator. So I have 2 times 2y minus 2x over 2 times 3y minus 2x. And so, of course, the 2's reduce. So dy dx is 2y minus 2x over 3y minus 2x. All right, and that is worth 2 points.
Yes. I'm kidding.
So most of you, or a lot of you guys, seem to know what was going on here. It's just that some of you guys were skipping a lot of steps. Now, I mean, I showed a lot. Do you have to show exactly every one of those pieces? You got to show enough so that it's clear that you know how to actually get to the result. Remember, they're giving you the answer here, right? So getting the correct answer is really inconsequential, right? You actually have to show enough of the algebraic steps so that it's clear that you know how to get.
It's so funny that he said that, Doug.
Well, the thing is like for some of you guys, when I look at your work, it's like, okay, maybe they know how to do it, maybe they don't. And the only reason I say that is because you don't show enough steps. So it doesn't really prove to me that you actually know how to do the problem. And that's what AP is looking for. When they're grading this, they're like, hey, you haven't really convinced me that you actually know how to do this problem.
Shouldn't getting the right answer convince you that we know how to do
Well, no, because they gave you the answer.
I guess
the answer is given, right? So like I know AJ,
Yes.
you're the type of person who's like, well, they gave me the answer. Why should I even do the problem?
Stop making
the
those
problem. You don't know what you're talking about, Mr. Bynum.
All right, whatever.
I just completely avoided doing number 2 altogether because I just couldn't figure out whether or not I was like looking for the equation of a circle or if I was actually doing implicit differentiation. I was just so stressed out from the amount of stuff I just couldn't recognize that I just kind of gave up and just did.
All right, well, that I hope that you're not going to do that on Tuesday. You know, I mean, you got to try to write something. Okay. All right. So let's move on to part B. All right. Part B says find the slope of the tangent line to the curve at each point on the curve where x equals 6. All right. So when I say I want to find the slope of the tangent line, that means I want to plug into the derivative, right? But if the derivative dy dx is 2y
Dude, I can't even see the whole screen.
minus
Dude,
2
his hand, he's left-handed.
Lily, your
Lily?
mic's on.
Lily, you're not muted.
Oh, are you left-handed, Mr. Bonario? Because I'm really confused.
Well,
I am
obviously, since you just called him out on it.
Do you want? What do you want
I'm
me to do?
sorry.
No,
Wait,
it's
what?
fine.
Are you?
I am left-handed. Yes,
I never noticed that before.
I've been left-handed the whole time you've known me.
It's 2020. Who's still left-handed?
I just noticed that.
All right, so I'll keep going and I'll try to be right-handed.
No, it's okay. I just couldn't see it.
All
So
right.
I was like,
All right.
because the left hand was covering it.
So our derivative is 2y minus 2x and 3y minus 2x, right? All right, so if I'm going to plug into the derivative, I need to know both x and y, right? So I can't plug in yet. So if I want to know x and y, I have to take x equals 6 and plug into the original equation, right? The original equation is 2x squared plus 3y squared minus 4xy equals 36. And so I'm going to plug in there for x equals 6, and then I'm going to be able to solve for y. And so that means I'm going to have 2 times x, so 6 squared, plus 3 times y squared, minus 4 times x, which is 6, times y equals 36. And so now I have a quadratic equation to solve, right? So we can simplify this a little bit, right? So obviously 2 times 6 squared, right, would be 2 times 36 or 72, right? But we could simplify this whole thing, right, and make it easier for ourselves, right? So if this is 2 times 6 squared, right, we could write 72 plus 3y squared minus 4 times 6, 24y equals 36, right? And if I subtract 72 or I subtract 36, however you want to write it, I would get 3y squared minus 24y. And then if I'm taking 72 minus 36, I get plus 36 and then equals 0, right? This is a quadratic equation. It was amazing to me how many people forgot how to solve a quadratic equation. Okay. Now, I know the numbers look annoying, but if you just divide by 3, right, you can make this much easier, right? So y squared minus 8y and then plus 12 equals 0. Now, let me tell you something else, people. This normally, like this would have been a non-calculator question, right? Like on an actual, like a regular AP test. But remember, people, you have your calculator available to you. So if you were just to take like this equation and set it equal to 0 and, you know, and graph it, you could pick out the zeros on there and that wouldn't be a big deal. Remember, you can use your calculator for whatever. Okay. Now, they have said that for this year, you know, the calculator is available to you, but it's not required. So, you know, if you get a question like this, go ahead and use your calculator. It's not that big of a deal. All right. But if you continue here, you can factor into y minus 6 and y minus 2, which means that y equals 6 or 2. Okay. Now, if y is 6 or 2, then that means there's 2 points, right? There's going to be a point that's going to be at 6, 6, and then another point at 6, 2, right? And the question says, find the slope of the tangent line to the curve at each point where the curve is x equals 6. So the way that that's worded, that would probably hint to you that there's more than one. Okay, and so now I'm going to evaluate dy dx at 6, 6, and then dy dx at 6, 2. All right, so dy dx at 6, 6, so I get 2 times 6 minus 2 times 6 over 3 times 6 minus 2 times 6, right? So 2 times 6, so 12 minus 12, of course, is 0 over 3 times 6, 18 minus 12, so 0, right? And then this one, 2 times y, so that'd be 2 times 2 minus 2 times x, which is 6, divided by 3 times y, which is 2, minus 2 times 6. All right, so guess what? You could just leave this alone, right? A lot of people, try to simplify and then they simplify incorrectly, and then we have that issue. So you can just leave it alone if you want, but of course you can simplify, right? So we get 4 minus 2 times 6, 12, divided by 3 times 2, 6, minus 12, right? So we get negative 8 over negative 6, or 4/3. Okay. Questions on part B? Questions?
No.
Will you
Really?
get points? Oh.
Okay.
Will you get points off if you don't put like at 6-2 or at 6-6? Just the two.
No. I mean, if your work shows like y = 6 and 2, and then you evaluate those, you're probably going to get that credit.
Cool.
How did you know you were allowed to have 2? Like, I solved for the 2 zeros, and then I was like, oh, well, I guess I better pick one.
Oh, well, okay, because the wording of the question, it says find the slope of the tangent line to the curve at each point on the curve where x = 6. So just the way that that's worded, you're kind of like, well, there might be more than one, the way that it's worded.
Okay.
Like one of those other questions says like, find this value or state that it does not exist. So when you get that it doesn't exist, you're like, oh, well, I guess they left that as a possibility.
Okay.
It's not really a leading question, but some of the wordings of the questions in that way do tend to lead you to, a particular type of response. I mean, really, knowing that there's 2 doesn't really tell you how to do the problem, but it might help you to think about whether or not you should add an additional answer. All right, let's go on to part C then. All right, part C. So obviously, like on part, like going along with that, AJ, it says find the positive value of x, right? So like when you solve this problem, you do get a negative value and a positive value, right? So if you don't exclude the negative value, then you're kind of, like you're not paying attention to the way the question is worded. So, all right, this one says find the positive value of x at which the curve has a vertical tangent line. Show the work that leads to your answer. All right, so what does vertical tangent line mean? Vertical tangent line means that the derivative is undefined, right? So that means like dy dx is undefined. Now, some people wrote like dy dx equals like 0 over 0, and that's no good. Remember, you want the derivative to be some sort of like non-zero over 0, right? Because then that means you have a vertical thing, right? If you had 0 over 0, then that means that's like indeterminate and you don't know what its value is. And so you need non-zero over 0, which very simply means what? That the denominator of the derivative is 0. And so your derivative, remember, dy dx was 2y minus 2x over 3y minus 2x, which means that we need 3y minus 2x to equal 0. Right? Now, believe it or not, you get 1 point if you simply set the denominator equal to 0. Okay, now you got to do some algebra. All right. So if this must be true, right? 3y minus 2x equals 0, then you could say, okay, well, that means what? That means that y would equal 2/3 x, right? Or you could say that x equals 3/2 y. You agree with that? Okay, now, it does say find the x value. So which version of these do you want? Well, you're going to want to use the y equals 2/3 x because if you look at the original equation, you're going to plug 2/3 x in for y, and so then you'll have an equation of just x values, all right? And so you've got 2x squared plus 3y squared, right? But y is 2/3 x, and then you've got minus 4xy, which is 2/3 x, and then equals 36. And now you just need to solve that equation for x.
Can
Right.
I take a closer look at that? Can I take a closer look at that, please?
Of course.
So, hold on. So 2x squared plus 3 2/3 x 2/3 x squared minus 4 times 2/3 x is equal to 36,
And so then we're just simplifying, right? So I'm just squaring those and multiplying those here. All right, and we can simplify a little bit. This 3 and this 9 would reduce to just be 4/3. So I have 2x squared plus 4/3 x squared minus 8/3 x squared equals 36. All right, and so I've got 4/3 minus 8/3, which would be negative 4/3, right? So I have 2, which would be 6/3 x squared minus 4/3 x squared equals 36. And so 6/3 minus 4/3, obviously 2/3 x squared equals 36. And so then I'm multiplying by 3/2. So x squared equals 36 times 3/2, right? And then of course you could just square root. X equals plus or minus square root of 36 times 3/2, right? And then obviously you need to remove the negative, right? So you get positive square root of 36 times 3/2, right? And you could just leave it like that. Remember, this is a numeric answer, so you don't have to actually do that simplification. But of course, if you do, 36 divided by 2 is 18, and 18 times 3 is 54. So you get the square root of 54.
So,
and you have, and it can only be the positive. The rubric says simplification is not required to earn the second point, but responses that include negative answers such as negative 3√6 or plus or minus square root of 54 do not earn the second point. Okay, and that is just worth 2 points.
all right.
All right, so that is that was part C. All right, and so lastly, all right, are we ready to move on to D? All right, so D. All right, let x and y be functions of time t that are related by the equation 2x squared plus 3y squared minus 4xy equals 36. So same equation. And then it says at time t equals 1, the value of x is 2. So at t equals 1, x is 2. And the value of y is negative 2. And the value of dy dt is 4. Find the value of dx dt. So this is a related rates question. So this is like section 5.3. But this is actually a much easier version of like a related rates question because they give you the equation. You don't have to come up with the equation. It's not in a context, anything like that. All right, so there's 2 ways that you can do it. All right, the first way is to take this thing, but you're going to take the derivative of both sides with respect to t, right? So you're going to take d dt of 2x squared plus 3y squared minus 4xy equals d dt of 36. All right, so now where you're taking the derivative with respect to t, right? So you have the derivative of 2x squared with respect to t is going to be 4x dx dt plus the derivative of 3y squared, which would be 6y dy dt, right? And then minus, you're going to have 4x dy dt, and then plus, this is going to be 4y dx dt, and then equals 0, right? The derivative of 36, no matter what variable you're taking it with respect to, is 0. All right, and so now you're just going to plug in your known quantities and solve. All right, so what do you know? You know that x is 2, so 4 times 2, dx dt, which is what we want to know, plus 6 times y is negative 2, and dy dt is 4. Minus, so make sure you distribute the negative sign, minus 4x, so minus 4 times 2, times dy dt, but dy dt is 4, and then plus 4 times y, and y is negative 2, times dx dt, which is what we want to know, and then equals 0. So now you have a relatively simple equation involving just dx dt, right? And I made a mistake. I did not distribute the negative sign here, so this should be minus 4 times 2, negative 2. All right, so now I've got 4 times 2 dx dt, so that'd be 8 dx dt plus an 8 dx dt. So I have a 16 dx dt. And then here, all right, I've got a 6 times negative 2 times 4. So this would be a negative 48. And then here I have a minus 4 times 2, 8 times 4, 32, right? And then equals 0, right? And so I'm going to add these over together. This makes 80. So I have 16 dx dt equals 80. So dx dt equals 86 or 5. Okay, now another way that you would do it, all right, is to recognize that we want to solve for dx dt, right? So if I had dy dx, all right, how would I get to dx dt? Well, dy dx, right, would be finding that derivative, but you'd have to actually have the chain rule involved. And so that would mean that to get there, you would actually have to have the derivative of dx dt in the result there. All right. I don't know, did anyone approach it like this? I had some people that did it kind of an interesting way, right? They said, okay, dy dx, right? They said, well, dy dx must be dy dt divided by dx dt. You see that? All right. And then they said that, okay, well, dy dx is, what was that? 2y minus 2x over 3y minus 2x, right? And then they were plugging in, right? And they were saying, okay, then that means that dy dt is 4 and dx dt is unknown. And then I have 2y, so 2 times negative 2 minus 2 times 2 divided by 3 times negative 2 minus 2 times 2. And so I get that 4 over dx dt is equal to negative 4 minus 4, so negative 8 over negative 6 minus 4 is negative 10, so 8/10. So I get that 4 over dx dt is 8/10. So if I take the reciprocal of both sides, I get that dx dt over 4 would be 10/8, right, which would be 5/4. And so if I multiply both sides by 4, I get that dx dt would equal 5. And so I get the same answer, but it's just kind of a little bit more kind of strange looking. Personally, I prefer the first way I showed that because it's much more like what we've done with related rates. So follow-up questions on part D.
No.
Mr. Dybus, anything to add?
No, I mean, that second way, the only person who did it that way was AJ, I think. And, you know, when you look at the rubric says like chain rule or product rule, and it doesn't really have either of those.
That's why I was confused about it, because like there was nowhere to put that.
Yeah. Yes, you didn't use either.
Well, okay, so the way that the rubric writes it is basically this in just a different order. So if you have dy dx equals this, right, you could rewrite and say then that dy dt divided by dx dt. So the way that they have it is by taking like dy dx and multiplying by dx dt. And then
Yeah,
I
I
have
saw that.
2y minus 2x over 3y minus 2x multiplied by dx dt. Both sides are multiplied by dx dt. And so that means that the dx's over here are going to reduce, leaving me with dy dt. Right? And that's ultimately, and really, if you think about that step, multiplying by dx dt, that's what I did. Didn't I? Because I took the reciprocal, right? So I got the dx dt here, and then I divided. So that, I mean, essentially, it's going to end up being the same thing. Where
That's why I was confused, because even in the second option on the rubric, it didn't look like there was the product rule or the chain rule. There's just no place for it.
Yeah, I mean, I think that this approach is still valid because you're recognizing the differential of each with respect to t.
Yeah, I had Mrs. Gordon.
I think it's still valid. It's just some people like tried this approach, but they didn't actually like show enough work, you know, to justify all of the points. So I think the thing is when you're doing like algebra within like a differential equation, right? So like when you're doing like algebra here involving differential equations, you know, then you want to make sure that you're showing those step by step because you're probably going to be getting credit for the steps as you're going. If that makes sense.
Also, make sure that you do the derivative of, I think it was 36, and actually set this equal to 0.
Yeah, yeah, that's another one. Like I said
some of you
earlier,
that part.
People just doing the derivative of one side, even though it seems like you intuitively understand that it's equal to 0. If you never actually write it, now somehow your work is lacking, you know, and then you leave yourself open to not getting a point that you should otherwise get. You know, so the big thing for a lot of you guys, you know, you seem to know what's going on a lot of these questions, but your work is somewhat, you're like lazy when you're writing it. You know certain things and you just don't want to write them. And so you really want to make sure that you are, you know, kind of overemphasizing the work that you're doing so that you're going to make sure you touch on, you know, all of those key points that you're going to get. And so like we said, we don't really know how these are exactly going to be graded, whether, you know, like, so yes, this is worth 9 points, right? And in the past, all the free response questions have been worth 9 points, you know, but this year, are they going to make this, instead of worth 9 points, they're going to make it worth like 15 points where they can give you an extra point here and there for indicating some additional details, you know, like in the L'Hopital's rule question, right? That was only worth, what was that worth? 3 points, right? Maybe that question becomes, now it's worth 5 points because they're going to give you 1 point for specifically stating, you know, the things needed for L'Hopital's rule. But then if you go ahead and use it, you know, then you're going to get an extra point, you know, something like that. Like before they would chunk, you know, points, like a single point, you'd had to have like 2 things to get it. But in this year, it's possible that now they're going to, you know, separate those points to just provide a little bit more variability between, you know, students who know a little bit more or write work that's a little bit better and show better justification for things. Okay. Other questions?
I have a question about like time management because I usually like run out of time. What's like the best way to like handle that, do you think? When taking this,
not simplifying numeric answers once you've arrived at an answer. You know, not stressing about that. That's definitely one thing. You know, you're going to have your calculator available. So if you can solve anything on your calculator, if you can, you know, do any of that, you know, you might want to try to do that. Being organized in terms of like, if you're looking up anything, you know, like, so we gave you those, that like kind of cheat sheet, you know, so make sure that you have those out and available to you. you know, but that you also have a lot of those details memorized. You know, so if you're like having to like look up a bunch of stuff, then you're probably going to slow yourself down. And then you're probably going to run out of time. I don't know, Mr. Davis, anything to add there?
I think with that cheat sheet too, just knowing like, being familiar with it, so that like if mean value theorem shows up, you know where on that cheat sheet the mean value theorem is, because, you know, it's whatever, 4 pages, like sifting through all of that on the spot, as opposed to knowing like, oh, the derivatives are on this page, theorems are on this page. Having that familiarity is going to speed up that process a little bit if you do have to rely on it.
What I did was I took a sheet of notebook paper and I wrote down what was in each unit for the notes. So if I recognize a problem, I can find it in my notes faster. I don't know if that would be helpful for you.
Yeah, I think that's probably helpful. You know, and a lot of these ones that we've done are, you know, we've tried to hit on ones that are, you know, really pretty likely to show up, you know, so like we're given that graph, you know, and then it's defined by a definite integral, you know, that's a really common one, you know, so looking those over, making sure that you're well versed in those. We did get a few of those. There's some additional questions that we could push out to you. Remember that those PDFs that Mrs. Gordon sent yesterday, Davis? We could always push some of those out. I mean, we could just push them out tomorrow or whatever. And if you guys wanted additional practice over the weekend, you could do those, and then we could give you solutions to those on Monday or something. You know, and those would be just good practice. But like AJ said, viewing some of those FRQ practice videos on the Advanced Placement YouTube channel, I think would be very helpful. There's like 30 some videos. I don't want you to view all those videos at this point. I really only want you to go into like the FRQ practice videos. So some of the FRQ practice was like from last week, like videos like 24 through 26. But then this week they were doing like the timed AP FRQ practice, which was kind of geared towards the FRQs that you guys are going to see next Tuesday. So that would actually be a great resource to use over this weekend. I mean, if you just go to YouTube and search advanced placement, you can get to all those videos, but we have it linked in, you know, in this week's and last week's agenda. And I can push it out again in a Skyward and Schoology link or whatever. You know, but really between now and Tuesday, we're not assigning anything else that's going to be due. You know, but there's a lot of materials out there that you can use if you want that additional practice. So if you go into My AP, there's a bunch of optional FRQs that are available to you that you could do. And correct me if I'm wrong, Mr. Davis, but they do have access to the rubric and things when they attempt those problems.
Yeah. Yeah. So even if we don't score it, you have access after submitting it to like the rubric, the scoring, so you can self-grade, or you should be able to.
Yeah. And so
really,
really
will be the same questions that we've done. I think maybe two of them.
Not many.
Yeah. But otherwise, there's still, you know, a good amount of resources for you to practice. And those are ones that are put together by the College Board as well. So, you know, there might be some good weight to them.
Yeah, I mean, really the biggest thing is it's Thursday today and your test is on Tuesday. And, you know, if you want additional practice, it is available for you, you know, and obviously Mr. Davis and I are resources for you as well. I'm planning on having a number of different Zoom meeting availabilities on Monday, you know, so I think, I mean, Mr. Davis and I haven't fully like discussed this, but I'm planning on being available like at 10 a.m. and then at like, you know, noon and at 2 and at 4, you know, like, so if you want to pop on and, you know, ask different questions or whatever, you know, then I think, you know, we want to be available for you guys just to make sure that you have all of the details that you need in place. Okay. You know, so there's two things. There's the content obviously we've been, trying to, make sure you guys are prepared for that, but then the logistics. So if you have not viewed the AP exam info video and then done the exam demo, then you need to do that because you need to make sure you are aware of the logistics of taking the AP exams. And remember, those are general. Those are for any AP exam. So it doesn't matter, that it's calculus related. It's for every AP exam that you're taking. So if you haven't viewed those, then you really do want to make sure you do those so that you are aware of what exactly that is going to look like. Okay. Any other questions?
Enrico.
Yes.
Can I just ask you a question on like the first effort Q we did?
Sure.
So, did we have to directly state that f prime of x is equal to 3 plus g of x? Because I solved it by just finding the critical numbers and then plugging.
What did you say were the critical numbers? You said -4, 0, and 3?
Yeah, and then I plugged those critical numbers into f, and then I found that f of 3 was the biggest. So then I said that was the maximum value, but I got 1 out of 2.
Well, okay, so if you're stating that x equals 0 is a critical number, that's actually not true, right? That would be that should be like a contradiction.
But
so like I understand like what you're saying, because just looking at the graph, x equals 0 looks like a critical number, but remember the fact that f prime is 3 plus g, and so 0 is not a critical number because that does not make f prime equal to 0.
What were the critical numbers of this?
Just the endpoints.
Oh, and then, so you just got so I got the point off because I stated 3 was a critical number, or 0 is a critical number?
That's what I would guess, yeah.
Okay, thank you. That's it.
Anything else? Jovanis looks like he's sleeping.
Wait, why did we even need to know f prime of x was 3 plus g of x?
Well, I mean, to find the critical numbers, right? You need to find f prime, but it just so happens that there aren't any places in that interval where g prime or f prime actually equals 0.
Okay.
So,
but yeah, in a different scenario, which a lot of the other problems we've had, there wasn't that like 3x plus. And so then you would have just said that f prime is g, and then wherever it did cross the x-axis would be the critical numbers. So we just wanted to show you a slightly different variation so that if they do put something like that on the test, that you're going to be, prepared for it because you're viewing it critically. And remember, every single one of you is going to have a different test. So like on Wednesday, like you guys could email me and you're like, oh, I had this question. And then somebody else is going to say, well, I had this question. Somebody else is going to say, I had this question. So really, we're just trying to show you as many different variations of problems as we can, so that when you get the variation that's going to show up on your test, you're going to be as prepared as possible.
So for extra practice over the weekend, you can do the optional practice that's available on the AP side, as well as look at the AP videos provided.
Yeah, so if you go to my AP, where we've been submitting all of our stuff, you should see a tab that says optional practice. It's just on the side of where your assignments show up. I could be wrong, but I'm pretty sure that's where it shows up. And then the College Board or the Advanced Placement YouTube channel, if you go on there, you can view the videos that they put out, which is going to walk you through a lot of things. But then they also have like a link where you can get the problems and things that they're going through. All right.
All right.
Any questions? I know that there seems to be some uncertainty about AP tests and things, and I get it. and we're trying to show you as much as we can with the constraints that have been put on us by both, like the RB administration and like the Illinois State Board of Education. I know we've given you guys a fair amount of work, but we've been encouraged to scale back the work that we're giving. And so we've been trying to balance making sure that you guys are prepared for the test with not giving you an overwhelming amount of work. So, anything else? Isabella, you all right?
I'm okay. I'm okay.
All right. All right. Anybody else? Alina, nothing snarky to say?
No, I'm just so upset.
I'm sorry.
Yeah.
Ask Amelia for a hug. It'll make you feel better.
I wouldn't want a hug from Amelia.
That's like my daughters are 2 years apart, and